Imagine you have a sketch of a toy car. The sketch tells you what a car should look like: 4 wheels, a seat, a steering wheel, but it does not give you a real built-up car you can play with. In programming, an abstract type is that sketch. It tells the computer what methods, actions, an object must have, but it does not give a complete usable object. We need abstract types because many different things share a common idea, like many different animals are all animals, but each animal can behave a little differently. An abstract type lets us write the common idea once and reuse it, while still allowing each concrete thing to fill in its own special details. In most languages, Java, C#, etc., you write an abstract class by putting the word abstract before the class name. Inside it, you can write abstract methods, methods that have a signature but no body. Example in Java. Public abstract class animal, open brace comment a field that every animal will have end comment protected string name semicolon, comment a normal constructor. This is allowed end comment public animal open parenthesis string name close parenthesis, open brace this dot name equals name semicolon close brace comment an abstract method. Subclasses must write the code end comment public abstract void make sound open parenthesis close parenthesis semicolon, comment a concrete method. Subclasses inherit this code automatically end comment public void eat open parenthesis close parenthesis open brace system dot out dot println open parenthesis name plus is eating period close parenthesis semicolon close brace close brace. Rules to remember. Number 1, abstract classes cannot be created with new. You cannot do new animal. Number 2, they may contain both abstract and concrete members. Number 3, any subclass that does not implement all abstract methods must also be declared abstract. Number 4, you can have constructors, fields, and even static members. These rules make an abstract class a half-finished blueprint that can also hold shared code. An interface is a pure contract. It only says what methods must exist, not how they work. In Java, you write it with the keyword interface. Public interface flying. All methods are abstract by default until Java 8. Void takeoff, void land. Default method provides a body that classes can use or override. Default void glide prints gliding smoothly. Static method belongs to the interface itself. Static void safety check prints all systems go. Interfaces cannot have instance fields, only public static final constants. All methods are abstract unless they are marked default or static. A class can implement many interfaces, giving it the ability to promise many different contracts. No constructors, you cannot create an instance of an interface directly. Think of an interface like a set of rules for a game. Every player must follow the rules, but the rules do not tell you how each player moves. Both abstract classes and interfaces let you describe a common shape, but they are used in slightly different ways. Inheritance extends. A class can extend only one abstract or concrete class. This is like a child inheriting a family heirloom. There is only one set of inheritance rules. Implementation implements. A class can implement any number of interfaces. This is like a student joining many clubs. Each club has its own set of promises. When a class extends an abstract class, it gets both the abstract method contracts and any shared code or fields that the abstract class already provides. When it implements an interface, it only receives the list of method signatures it must fulfill, no shared code. In many languages, you can combine both. A class may extend one abstract class and implement several interfaces. Visually, imagine an abstract class called abstract animal and an interface called flying. An arrow points down from each of them to a concrete class called dog. From dog, there is a line indicating it implements flying. Here, dog inherits behavior from abstract animal and promises to follow the flying contract. Explanation: how do you decide which one to use? Think of a toolbox. Use an abstract class when you have a family of things that share a lot of code or state. Example: all shapes have a color field and a method to compute area. Put that shared code in an abstract class so you don't repeat it. Use an interface when you only need to guarantee a capability that can be added to many unrelated classes. Example: serializable or comparable. Any class can become serializable without sharing a common ancestor. Practical guidelines. If you need instance fields or default implementations that many subclasses will use, abstract class. If you need multiple inheritance of type, a class must act like many things interface. If you anticipate the language may add new methods to the interface later, prefer abstract class with default methods, or use interface default methods if supported. Remember the single inheritance rule. You can only extend one class, so reserve abstract classes for the core hierarchy. A simple rule of thumb: if it is a what is it relationship, use an abstract class. If it is a what can it do relationship, use an interface. Polymorphism is the magic word that lets one variable hold many different concrete objects, as long as they share a common type. When you write animal A equals new dog, animal B equals new cat. A and B are both of type animal, even though the real objects are dog and cat. The compiler checks that dog and cat both fulfill the contract of animal, that is, they implement all abstract methods. At runtime, when you call a dot make sound, the correct version for dog runs. This is called dynamic dispatch. Interfaces give the same power. For example, list of string list equals new array list, list add hello. List could later be a linked list or any other class that implements list. The code using list does not need to know the exact class, it only relies on the contract that list provides. This enforcement of contracts makes programs safer and easier to change. In child-friendly terms, imagine you have a remote control car, the interface that can go forward, backward, and turn. Any brand of car that plugs into the remote must understand those 3 commands. You can swap the car without changing the remote. The remote knows exactly what commands it can send, nothing more, nothing less. GUI frameworks. In Java Swing, java.auth.component is an abstract class that provides the basic drawing and event handling code. Specific widgets like JButton or JText field extend component and add their own look and feel. Data structures. The Java Collections framework defines the java.util.collection interface. Classes like ArrayList, HashSet, and LinkedList all implement this interface, so you can write code that works with any collection without caring about the concrete class. Operating systems. In Android, Activity is an abstract class that gives you the lifecycle methods onCreate, onPause, and so on. Your app writes a subclass that fills in those methods. These examples show how developers write reusable high-level code once in an abstract class or interface, and let many concrete pieces plug into it, saving time and reducing bugs. A vector space is a mathematical structure that follows a set of rules. Formally, a vector space V over a field F must satisfy. Closure under addition. For all U, V and V, U plus V is in V. Associativity of addition. U plus V then plus W equals U then plus V plus W. Commutativity of addition. U plus V equals V plus U. Existence of zero vector. There exists 0 in V such that V plus 0 equals V. Existence of additive inverse. For all V and V, there exists negative V and V with V plus negative V equals 0. Closure under scalar multiplication. For all in F and V, a times V is in V. Distributive properties and compatibility with field multiplication. Public abstract class abstract vector space, open brace protected int dimension semicolon protected double, array coordinate semicolon public abstract vector space, open parenthesis int dim close parenthesis, open brace this dot dimension equals dim semicolon close brace public double norm open parenthesis close parenthesis, open brace double sum equals 0 semicolon for each double C in coordinate sum plus equals C times C semicolon return math.sqrt. Open parenthesis sum close parenthesis semicolon close brace public abstract vector space, add open parenthesis abstract vector space, other close parenthesis semicolon public abstract vector space scalar multiply, open parenthesis double scalar close parenthesis semicolon close brace. The abstract class gives a common field dimension and a ready-made method norm. Public interface vector space ops, open brace vector space ops, add open parenthesis vector space ops, other close parenthesis semicolon vector space ops, scalar multiply open parenthesis double scalar close parenthesis semicolon, double norm open parenthesis close parenthesis semicolon close brace. Here the interface only declares the operations. Any class, a real vector, complex vector, or even a sparse vector can implement the interface and provide its own storage strategy. When to pick which? Use the abstract class if most vector types share the same storage representation, or helper methods, for example an array of doubles. Use the interface if you want to allow completely different implementations such as arrays, linked lists, GPU buffers, but still guarantee the same mathematical operations. Both approaches let mathematicians write algorithms that work with any vector space, without caring about the concrete details. Testing code that depends on abstract types is easy because you can replace the real implementation with a test double, a mock or stub that behaves in a controlled way. Mocking an abstract class. Many mock frameworks such as Mockito and JMock can create a subclass on the fly that implements the abstract methods with dummy behavior. Abstract vector space mockvec equals mock of abstract vector space dot class. When open parenthesis mockvec dot add open parenthesis any close parenthesis, then return mockvec. Comment define what add should do. Mocking an interface. Interfaces are even simpler to mock because the framework only needs to provide implementations for the declared methods. Vector space ops mock ops equals mock of vector space ops dot class. When open parenthesis mock ops dot norm open parenthesis, then return 5.0. Manual stub class. If you prefer not to use a library, you can write a tiny concrete subclass just for the test. Class test vector extends abstract vector space, opening brace public test, vector open parenthesis, in dim close parenthesis, open brace super open parenthesis, dim close parenthesis, semicolon, this dot coordinates equals new double open bracket dim close bracket semicolon close brace. Override public abstract vector space, add open parenthesis abstract vector space, o close parenthesis, open brace return this semicolon close brace, override public abstract vector space. Scalar multiply open parenthesis double s close parenthesis, open brace return this semicolon close brace closing brace. Why mock abstract types? They let you test code that uses the abstract type without pulling in heavy dependencies such as a database connection. They allow you to simulate edge cases such as an add method, throwing an exception that might be hard to reproduce with a real implementation. In simple terms, think of a mock as a pretend toy that follows the same rules as the real toy, but you control exactly how it behaves so you can check that the rest of your program reacts correctly.